Alright, cool. So welcome on back. This is for Algebra 2 Test 3. So guys, we're getting ready for our third test, and we're going to be covering just a couple of topics this time around. Quadratic formula, and discriminant, rational equations, and complex numbers. So let's go ahead and start with our quadratic formula. Okay, so on this test there's really four different things you have to remember, and both of those things have to deal with the quadratic formula slash its discriminant. So we'll talk about those two things first. So quadratic formula and its discriminant. I'm just going to shorten that to that. Okay. So with quadratic formula, there are a couple of things that we learn. First off, you learn how to do, just with the property of radicals, how to solve a given value. And then you also figured out how to just use the quadratic formula. So let's talk about our quadratic formula and what it is. So quadratic formula is as follows. So quad formula, oh my. Quadratic formula is just negative b plus or minus the square root of b squared minus 4ac, all that in the same square, all over 2a. Alright, and we talked about a lot of different ways to remember this one. There are a couple of different ways to memorize it. Feel free to find a mnemonic. Either way, you need to know this for your test. And to do this, you also need to know that all of your quadratics have to be set up to where they're equal to 0. So give an example like the following. X squared minus x minus 42, and we're going to end up with a really pretty answer for this one. So this first example is going to be pretty, and we'll talk about what happens when they're not pretty in a little while. Okay, some of you guys may recognize this. It is from your book, that page 95 assignment. So given this example, you have to remember that in front of every single one of these there is a coefficient. So in front of x squared there's a coefficient of 1, in front of negative x there's a coefficient of negative 1, and in front of, sorry, there's no letter over here, but you also have negative 42, and it is a coefficient in and of itself. So you have to be able to label a, b, and c. A equals 1, so a is always attached to x squared, or b squared, c squared, whatever this variable is, as long as it's to the second power. The coefficient in front of that one is going to be your a. Coefficient in front of the variable with just one exponent is going to be b, so b is negative 1, and c here is negative 42. Alright, and these could be any numbers depending on the problem. So if this were a 2x squared, that would be 2. If this were a positive 100x, b would be positive 100. Doesn't matter. It goes in order. Make sure that it always equals to 0. Okay? If it does not equal to 0, so if this was a 10, we would have to subtract 10 from both sides. We'll do an example like that in just a second, because you will get that on your test. Alright? After we've named a, b, and c, all it comes down to now is, can we plug them into our original quadratic formula? So we have things like a negative sign. So let's start with that. In fact, I'll write my example in green. So you have a negative sign, and then there's a b, but you don't write b, so our job is to replace all the letters. So instead of b, right after that negative sign, we're going to write what our b is, and our b is negative 1. Go ahead and put it in parentheses. Alright. Next is that plus or minus sign, and then the square root sign. And then again, you'll see that we have another letter, b squared. So instead of b squared, we were going to write negative 1 squared. Alright, and then minus, there's a 4 built into the equation, but then there's a and c. We got to replace a and c. A was 1, okay, so we place a 1, and then c is negative 42, so we're going to place a negative 42. I'm going to go and extend my radical line. Alright, because remember, everything's underneath that radical. Sometimes you will run out of room. You'll just have to make that line a little bit longer. And all of this is all over 2. Alright, and then times a. Remember, we don't write the letters. We got to replace them. A was 1, so we'll go ahead and replace it with a 1. Alright, and that's how to use your quadratic formula. From here on, you just need to hopefully grab a calculator. If not, you'll have to do it by hand. It's not too hard either way, but a lot of them do turn out really, really ugly. So you will need, decimal answers to that kind of thing. So a negative, negative 1. Alright? Whenever we have a negative and a negative, it becomes a positive. So we're just going to write this as a positive 1. Plus or minus square root of, and I'm going to simplify all this in one step. You can write it out in multiple steps, but I'm going to simplify all of it at once. So 1 squared is 1. minus 4 times 1 times negative 42. So these two negatives, negative 4 times 1 is just negative 4, and the negative 4 times negative 42 is a 168. So it's a negative times a negative, so it becomes a positive 168. So it's 1 plus 168, which gives us 169. All over, and this is 2 times 1, so we're just going to write 2. This is the last part of your problem. You are pretty much done. The square root of 169 is 13. So if you just type this into a calculator, you would get 13. And now you have to split this up into two different problems. Let me go ahead and get an orange, or my black marker will work here. So we break it up into a problem. First, we'll do 1 and then pick one of these signs. I typically start with a plus sign first. So 1 plus, and remember the square root of 169 is 13 over 2. And we also have 1. We're going to write this in red. 1, instead of plus now, we have to use our minus sign, minus 13 over 2. 1 plus 13 is 14, 14 divided by 2 is 7, and then 1 minus 13 is a negative 12, and negative 12 divided by 2 is a negative 6. And that is how you would finish off this problem. It will not always work out to where this is a perfect square. You will get 1 on your test where it is a perfect square. You will get 1 on your test where it is not a perfect square. And when it's not a perfect square, you just type it in a calculator, you'll get a decimal. For purposes of the test, and I will make sure to write it on the test as well, but when the directions say to round to the nearest 100th place, or round to 2 decimals, okay, so I'm telling you right now, it's going to be round to 2 decimals. Make sure you have those 2 decimals, make sure you know how to round, okay? So that's how to use quadratic formula. Let's go ahead and talk about quadratic formula and its discriminant. So if we take a look back here before I move on to the new page, this part underneath the radical is actually called the discriminant. And that discriminant is going to be used to tell us things about our graphs of these equations. We're not graphing yet, but this just tells us a little something about our answers. Okay, so let me go ahead and get a new sheet of paper, and let's start here with just the discriminant. Alright, so remember that discriminant is just that area underneath the radical, so b squared minus 4ac is called your discriminant, spelled like this. If you need to, YouTube other videos, Khan Academy, Google, it's spelled like that, so you can find the discriminant, okay? And on the test, I'm going to give you an equation. I'm going to give you something like negative 2x squared plus 6x minus 8, or plus 8. There you go. And I'm going to give you this equation, and I'm going to ask you to, first off, let me write it in red. Actually, let me write it in black. So I'm going to ask you to find the nature of its solutions. And what it'll be worded on the test is, please find the nature of the following equations, or the nature of the roots of the following equations, and the nature of the solutions of the following equations. Find the nature of its roots. Okay, and what it's asking you to do is first find discriminant. So first, let's find discriminant. Okay, so find discriminant, b squared minus 4ac. Let's go ahead and name our a, b, and c. A, b, c. So c is 8, b is 6, and a is negative 2. Let's go ahead and plug that into just this discriminant. So instead of b squared, I'm going to write 6 squared minus 4 times, instead of a, I'm going to write what you called a is negative 2. And then instead of c, I'm going to write our 8. From here, we just have to do the math. 6 squared is 36 minus negative 4 times negative 2 is a positive 8. Positive 8 times 8 is a positive 64. And what you'll get here is 100. Now that you have this, you have your discriminant. So your discriminant is 100. Okay? So that's our discriminant. Now to the part that you have to memorize. These are the other 3 things that you have to memorize for this test. And technically there are more conditions than this, but these are the only 3 that I'll be testing on. All of your answers will fall under one of these 3 answers. So either the discriminant equals 0, and if the discriminant equals 0, then you have one rational root. Okay? One rational root. If the discriminant is greater than 0, you then have to ask yourself, is it a perfect square? I'm going to shorten this a little bit. Okay, so is it a perfect square? If it is, then hooray, you have 2 rational roots. But there's one more condition, if d is greater than 0, but it is not a perfect square, not a perf square. So if it is not a perfect square, then you have 2 irrational roots. Alright, and so it has to follow in one of these 3 conditions. For the test, all of yours will follow under these. There are technically a few more, but I haven't gotten to that lesson just yet. So we're just going to introduce these 3 for now. So first off, let's take a look at our discriminant from our problem above. So after you found it, you found your discriminant is the number 100. Is 100 equal to 0? No, 100 and 0 are not the same, so it is not this answer. Okay? Is 100 greater than 0? Yes, yes it is. So that's good. We're good so far, but is it a perfect square? Yes, yes it is. So that means your answer is 2 rational roots. If instead this number was, I don't know, 99, then 99 is greater than 0, but it's not a perfect square, so you would write 2 irrational roots. You're going to get 3 or 4 of these problems on the test, and they're just going to ask you to either find the discriminant and then tell me the nature of its roots, or it's just going to give you the discriminant and then ask for the nature of its roots. Okay? So those 3 conditions you do have to memorize for the test. So you have to memorize these, and you also have to memorize your quadratic formula, which was on this last page right here. Okay? So you have to memorize that, memorize those 3 things, and you will have everything that you need memorized for the test. Let me go ahead and note one thing real quickly though. On your test, you will receive questions that are a little bit different, like this. So I told you this earlier, and you guys have heard this in class a few times now. You will get problems that are not set up properly. I told you they have to be equal to 0, right? So let's go ahead and give you a different example. 2x squared plus 6x equals negative 8. If this is not equal to 0, that's a negative 8. That's clearly not a 0, but we can make this 0. If you add 8 to negative 8, you get 0. In which case now your equation becomes negative 2x squared plus 6x plus 8 equals 0. Okay? And then you would be able to proceed with your problem like normal. In fact, you actually just did that earlier. Negative 2x squared plus 6x plus 8. Negative 2x squared plus 6x plus 8. Okay? So you will get problems like this. Do not make the mistake of labeling your C negative 8. Your C is not negative 8. It has to equal 0 first, and then you label A, B, C. So C in this problem is actually supposed to be a positive 8. Don't get tripped up by that. Okay? So that's quadratic formula and discriminant. Those are both of the ways that we are going to have problems on this immediate test. Hopefully that makes sense. Let's go ahead and move on real quickly. We're going to move on to complex numbers. In complex numbers, we covered a lot of ground. So there are a lot of different kinds of problems that you can get. The first thing you have to remember is that our basic chart repeats over and over and over. So let me go ahead and grab a sheet of paper for that. Alright, that's fine. One sheet of paper, there we go. Okay. So with complex numbers, you have to remember, so these are complex or imaginary numbers. These are those i's that we talked about in class. Complex numbers. Okay. So the basic chart is this. I to the first power is just I, or the square root of negative 1. I to the second power is negative 1. I to the third power is negative square root of negative 1. Or I, you can just call it I either way. Or negative I, sorry. So you'll notice that this and this are exactly the same thing. Don't really worry about it too much. You only need to memorize 1. And then I to the fourth is positive 1. And then these 4 values repeat over and over. So I to the first, second, third, fourth. And if you have to go to the I to the fifth, you just start back at the beginning. 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, etc., etc., etc. And you can keep going over and over infinitely. The one thing that we have to be able to remember with this is that I'm going to ask you problems that look like this. Example. What is or simplify. Honestly, the directions will say simplify, but all right, what is I to the 9th? And then there are two ways to do this. The easiest, or I'm sorry, the way that's really, really simple that anyone can do is they go like this. Well, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. So I to the 9th must be equal to the square root of negative 1. Pretty easy. But let's say that this is actually a little bit more troublesome, and I'm going to give you a more annoying example, which on the test, by the way, you will get an example that's fairly easy to count like that. But remember, you can also get an example that looks like this. What is I to the 281st? 281st. So let's go ahead and figure this out. You could just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you could do this 281 times. But that bloody sucks, so let's not do that. Here's the other way to do that, okay? Just take your exponent, and because it cycles every 4 values, go ahead and divide it by 4. It doesn't matter what your answer is. What you're actually looking for is the remainder in the problem. So if you already know the remainder by looking at this, great. If you don't already know the remainder by looking at this, let's go ahead and work it out. So 4 goes into 28 7 times. 28, 0, bring down the 1. 4 goes into 1, 0 times, 0, 0. Your remainder at the end, so you end up with a remainder of 1. Okay? So if your remainder here is 1, what you have to do is look for the 1 with the first exponent. If your remainder was 2, look for 1 with the second exponent. If your remainder was 3, look for 1 with the third. By the way, the only weird one is if you get a remainder of 0. So if it goes in perfectly, you actually put I to the 4th here. Okay? Or if you want, you can remember that I to the 0. Remember, this just cycles, right? So it goes I to the 1st is that, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. Well, if we go backwards, the thing right before the square root of negative 1 would just be 1. So, and it just repeats. So, however you want to memorize it, in any case, if you know these 4 values, all you have to do is divide by 4 and find a remainder. Whatever that remainder is, look for the matching exponent. Okay? Remember, these are in your book, page 104, if you need to practice them. Alright, beyond that, we've got a couple other types of complex number problems. You're also going to get this kind of complex number problem. We'll start a new area right here. So you should get an example like this. Find the square root of negative 10. Something like that. Actually, let's do negative 100. Okay? So the square root of negative 100 is going to be simply the same as the square root of 100, but you have to do something. As soon as you see that negative sign, pull out an I first and foremost. So that's the biggest thing. And then treat it like a regular problem. Get rid of the negative sign. We all know that the square root of 100 is just 10. So your answer here is 10I. And we introduced in class that all of your answers technically have 2. So the square root of any given number has 2 values. Okay? Just like in your quadratic formula, you have that negative b plus or minus. So when you take the square root of 100, technically you have a plus or minus 10. Remember, the reason for that is because positive 10 times positive 10 is 100. Negative 10 times negative 10 is 100. And then you just tack on that I. Okay? In a slightly harder example, it could be something like this. Square root of, I don't know, 120. Alright. And then this is a negative 120. So remember, when it's a negative, you just have to pull out I and treat it like a regular problem. From here, we just do that factor tree thing. So, let's see. 4 times 30. And that's actually going to be it, but you could go all the way here, and you could go, alright, well, 10 times 3, 2 times 5, and then 2 times 2. You're looking for pairs, so there's a pair, so you pull out 2i, and then the square root of, there's no more pairs, so you got to put 2, 5, and 3 back underneath. 2 times 5 times 3 equals 30. Alright, and I know I went through that quickly, but we've gone over simplifying radicals a lot. Hopefully you guys remember this from the beginning of the year. Or not beginning of the year, sorry, beginning of the quarter. Most of you guys handled this quiz really well. So, I'm going to go ahead and leave it at that. Alright, so the 2 things we've covered so far is how to simplify I to any power, and then how to simplify negative radicals. After that, we have to be able to Add and subtract complex numbers looks kind of like this. So this is adding, subtracting complex numbers. Okay. So let's add and subtract complex numbers. This is actually really simple too. Remember, I is just a variable. It's a lot like x. So if I have something like this, 3i minus 10 plus 2i plus, I don't know, 12i. Something like this. Given a problem like this, you'll notice that there's a random 10 in here, but there's no other number without an I. We cannot combine this because it is not a like term. But you'll notice that has an I, that has an I, that has an I. We can combine these. 3i plus 2i is 5i, plus 12 more i's gives us a total of 17 i's. So your final answer here would just be negative 10 plus, what was that, 17i. Okay, and it was just basic addition, 3 plus 2 plus 12, and then tack on the I at the end there. And remember, whenever we're adding terms with variables, you can always remember if you need to replace that I with something else, think of it like eyeballs. 3 eyeballs plus 2 eyeballs plus 12 eyeballs is 17 total eyeballs, okay, or eyes. It's a pretty simple idea. Remember how to add and subtract your like terms. Hopefully we still remember how to do that. All right, so that's combining like terms. The one thing that they did in the book and that you will get on your test is that they might do this to you. 3i minus 10, but then they did this, 2i plus 12i, something like that. And you'll notice that this problem, even though it looks almost the same, is slightly different. There's this negative sign here, and that negative sign is a big deal. Whenever you have a negative sign outside of a parentheses, you have to distribute to everything inside. So this all stays the same. But this stuff after the negative sign changes. That negative sign makes that positive 2i negative 2i. And that negative sign makes that positive 12i negative 12i. So it just becomes the opposite. And so this problem is actually going to have a slightly different answer. 3 i's minus 2 i's is 1 I. And then 1 I minus 12 more i's is going to be a negative 11 I. And there's still that negative 10 at the beginning. Alright, so just remember to distribute that negative sign. Alright, and that's adding and subtracting complex numbers. We had 2 more types of problems that you had to deal with. Or, I guess, 2.5. I'm going to cover all 2.5 of them on one page because they're all fairly related. First off, you have to be able to FOIL i's. Remember, foiling i's shouldn't be too hard. Looks like this. 3i plus 1. And, I don't know, 3 plus I. You'll notice that this one is in standard form. The number comes before the I. This one's not in standard form. For this type of problem, it doesn't really matter too much, but some people might want to flip these around. It doesn't really matter to me. You're going to get the same answer for this type regardless, but you should practice putting things in standard form. So I'm actually going to rewrite this problem so that my number comes first and my I comes second. 1 plus 3i. Again, for these earlier problems, it really doesn't matter, but it does matter in the future for these problems that are going to come after this. So I would recommend you get used to putting in this order just so that you get practice with it. And then let's FOIL. So first times first is 3, 1 times 3. So that's the first terms. Now let's go outer. So 1 times I. 1 times I is just I. And then the inner terms. So 3i times 3 is 9i. And then last, 3i times I is 3i squared. And then let's just combine like terms. 3 plus our like terms are right here in the middle there. I and 9i, let's add them together. And then 3i squared. Now this looks like you'd almost be done with the problem because we don't have any like terms left. But I squared, if you'll remember from our initial chart, I squared has a very distinctive value. I squared is negative 1. So when we get I squared, or if we get I to the fourth, we do need to replace those with our negative 1 and positive 1. Because they're such easy numbers, this is called simplifying, and negative 1 is clearly simpler than I squared. So let's plug in negative 1. So instead of I squared, I'm going to rewrite this 3 plus 10i plus 3, but not I squared, it's negative 1. And then let's go ahead and do the math real quick. 3 times negative 1 is a negative 3, so 3 plus 10i. And instead of regular 3, it's 3 times negative 1 is negative 3. And you'll notice 3 minus 3 is 0. You're just left with a positive 10i. So your final answer here is just 10i. Hopefully that didn't throw anybody off. Let me go ahead and get this on screen again. A lot of these steps can be put into one. Do remember that there is a fast way to do everything that I'm doing. I'm just writing out every single step so you guys can follow along. Okay? So that is foiling i's. After we foil terms with i's, we also have to be able to simplify with I in the denominator. Okay? So you are going to get times where you have I in the denominator. And there are going to be two types of problems where this happens. Okay. So, if you have the following two examples, so there are going to be two types. And we'll get to this one on the right in a little bit. Let's start with this one on the left. It's going to be a problem where you just have an I in the bottoms. So it could be anything in the top, and this could be really long, like 3i minus 1 plus 2 plus 8 plus blah, 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 blah. A really long problem, but I'm just going to put it all over I like that. Alright, and you're going to get a problem that looks just like this on your test, except that'll probably be a 4 or something like that. Okay, and to get rid of this I, all you have to do is something called rationalizing the denominator. We can't have a radical in the denominator, and I is technically a radical. Wow. So you're just going to go ahead and get rid of it by multiplying by itself. You're going to multiply by I over I. From here, you just have to distributive property all of this. Okay? So we just multiply. I times I is I squared. That's good. That's your bottom part. Great. But what about your top? So 3i times I is 3i squared. Negative 1 times I is just a negative I. And then I just told you guys earlier, we can't have I in the denominator, but you guys know what I squared is. If you've forgotten, remember, you have to memorize your chart. I squared is negative 1. So, if I squared is negative 1, I can rewrite this as 3 times negative 1 minus I all over negative 1. Okay. From here, let's go ahead and simplify. 3 times negative 1 is negative 3 minus I all over negative 1. And I would actually accept this as a final answer, but if you wanted, you could go one step further and simplify by pulling a negative 1 out of everything, and you'll get a positive 3 plus I over positive 1, or 3 plus I. And this would be your final answer. Like I said, I don't really mind, and I will give you full credit if you stop here, but you really should be able to simplify to this. Okay? So on your test, if you simplify to this, you're much better off than here. If you can reduce a fraction or simplify a fraction, you definitely should, in all cases in mathematics. Alright, so that's the first example. That's just if you have a regular I in the bottom. But what if you don't have a regular I? What if it looks like this instead? Let's go ahead and flip this. I'm going to put it upside down. And I'm going to do it like this. Virtually the same problem. Okay? But it's flipped. And I've moved these around to standard form. Okay? So the first thing you have to make sure is, again, make sure it's in standard form, because now that it is, we can get rid of it. You can't have an I in the denominator. To get rid of this, you have to do something called multiplying by the conjugate. Okay? And the conjugate is always in standard form. You're just going to take that middle operation and you're going to change it. So instead of negative 1 plus 3i, it'll be negative 1 minus 3i. Okay? So conjugates are really easy, and let me go ahead and get another sheet of paper real quick, and let me just run a couple of conjugates. So if you use something like 10 minus 12i, the conjugate is just going to be 10 plus 12i. If you have something like 50 plus 108i, the conjugate is just 50 minus 108i. So you'll notice that conjugates are never difficult to find. Okay? So don't worry too much about that. You just have to change that sign in the middle. Let's go ahead and change that sign here. So instead of instead of negative 1 plus 3i, you're going to write negative 1 minus 3i. And what you're going to do is you're going to write it over itself. From here, you just have to apply the laws of FOIL that you just did on that other sheet. So let's go ahead and just FOIL out the bottom. So let's do the bottom part first. FOIL first times first. -1 times -1 is 1. Okay. I should have written this a little lower here. And then outer, so -1 times -3i is a positive 3i. Inner is positive 3i minus 1. Or I'm sorry, positive 3i times -1 is going to be a negative 3i. And last, 3i times -3i is a negative 9i squared. You'll notice something interesting about this. You'll notice that these two here, 3i minus 3i cancels out. And your middle terms are always going to cancel out. So you can go ahead and ignore those. You will end up with just 1 minus 9i squared. But remember, 9i squared, I squared is -1. So -9 times -1 is a positive 9. Plus 1 is a 10. So on the bottom here, you just end up with 10. But what goes on top of all this is just that I times all this stuff. So I times -1 is negative I times -3i is a negative 3i squared. And again, I squared we can simplify to -1. Negative 3 times -1 is a positive 3. So this is really negative I plus 3 all over 10. And you'd be done with this problem. I know I went through that quickly, but it is just FOIL. Except that you can now, because of the conjugate, eliminate the outer and inner parts. That middle part will always disappear. Now, if you want to just go ahead and write it out like I did, that's perfectly fine on your test. If anything, that'll get you more points, so you're good. If you want to just skip this entirely and skip to the end product here, I completely understand that too, and I would not have a problem with that. Alright, so hopefully we remember our complex number rules. We've already gone over this like crazy, so I'm not going to spend too much time on that. Our very last type of problem that we're going to run into on our test is going to be rational equations. So this is the very last thing that we covered, and I told you guys to limit yours to just a couple of different types of problems. So here's the first type of problem. I did that one in class like crazy, so let's go with this one instead. P over 4. So these are, by the way, rational equations. Rational equations. Alright, so P over 4 plus 18 equals 56. Alright, so I would get rid of this plus 18 first, because our goal in any rational equation is to solve for the variable, so solve for P. So let's get rid of this 18 first. You'll get P over 4. 18 minus 18 is 0. Bring down your equal sign. And then 56 minus 18. So 56 minus 18 gives you a 38. Wow. Really? Okay. Well, this problem doesn't turn out quite as nicely as I would have wanted it to, but that's okay. And then so from here, you have P divided by 4. To get rid of divided by 4, you have to do the opposite. So we'll go ahead and multiply by 4. You will get P is equal to 38 times 4. 2, 3... Wait, was that it? Oh yeah, I'm sorry. There you go. 152. Sorry about that. And so your final answer here would be P is 152. And you could check that by plugging it back into your equation up there. So 152 divided by 4 plus 18 to check it, but it will be fine. It all works out. Alright. On the test, you will get questions like that. That is the most basic of rational equations. But let's go one step harder. Alright, you'll also receive questions that look like the following. Let's go ahead and do this one in black. Alright, I think I did that one a lot, so I'm going to do 17. So this one looks like this. X plus 6 over x plus 4 equals -5 over 3x. And when I taught this in class, I only taught one way to the class. There are a couple ways to actually handle this, but we're just going to handle it the same way we handle it in class for now until I get to the other ones. Until I can demonstrate them for you, I'll just stick with this one style. So what you'll want to do here is you have a fraction equal to another fraction. When you have that, you can go ahead and cross multiply. So let's multiply the top by the bottom and the bottom by the top. So I'm going to do this one times that one first. 3x times x gives you 3x squared. And then 6 times 3x gives you 18x. Alright, and then let's put our equal sign and then do the other one. So we did that one and that one. Now let's do this one and this one up here. -5 times x is a -5x. And then -5 times 4 is a -20. From here we just have to combine like terms. So let's move them all to one side of the equal sign. So I'm going to add 5x, And I'm also going to add 20. Add 20. So 3x squared has no like terms. 18x plus 5x. 18 plus 5 is 23x. Oh my gosh. Well, we'll just there. 23x. And then you've got that plus 20 at the end. All equal to, remember, negative 5x plus 5x, so a negative and a positive, they cancel out. Negative 20 plus 20, so 20 minus 20 is also canceled out. This is all 0. So you've got equals 0. This should look really familiar to you, and you would just finish it off by doing quadratic formula, factoring by grouping, and those are the only two styles you've learned to use them right now, and you would just finish them off that way. Whichever way works, you can absolutely use either quadratic formula or factoring by grouping. I think in this case, quadratic formula would probably be easiest. So you would just set up your whole quadratic formula, and you would set it up like this. So again, let's go ahead and label our A, our B, and our C. Now let's go ahead and plug them into the formula. Remember the formula from earlier on is negative b plus or minus square root of b squared minus 4ac all over 2a. Now let's go ahead and start plugging things in. So negative, but not b. Okay, so we had to put in rb is 23. Plus or minus the square root of not b squared, but 23 squared. Minus 4 times, and then not just a, it's going to be whatever our a was. So remember our a was 3. And then our c was 20. And I'm kind of running out of room here, so I'm actually going to continue this on another sheet of paper because right now it's too small for you guys to see. 1 second. Alright, let me just rewrite that really quickly. So negative 23 plus or minus square root of 23 squared minus 4 times 3 times 20. And then all over 2 times a, or 3. And from this point on, you would just grab your calculator and you would start typing things in. Let me go ahead and grab my calculator real quickly, and we'll figure this out. Okay, so you've got negative 23 plus or minus, and if you type all this into a calculator, so 23 squared is 529 minus 8240, and you get 289. All over 2 times 3 is 6. Okay, and if you type in your calculator, 289, I didn't know this. The square root of 289 is actually 17. So you've got negative 23 plus or minus 17 all over 6. Sorry about that. And then from here, we separate it into our two different problems, so negative 23, and then we use the plus sign, 17 over 6, and then ooh, that's a sloppy 6. And then negative 23, instead of plus, we use minus 17 over 6. Let's go ahead and do the math. Negative 23 plus 17 is a negative 6. Negative 6 divided by 6 is negative 1. Over here, negative 23 minus 17 is a negative 40. And negative 40 over 6 can be simplified. So negative 40 over 6. We're going to simplify it down. It's going to go a little further. 2 goes into both of these. So you're going to get negative 20 over 3. And those would be your two answers here. Okay? Rational equations can absolutely lead you into factoring. It just depends. You can have easier rational equations as well. So I'm actually going to do a slightly easier example of this. But that is what you would do in the hardest rational equations. You will get a problem like this. Okay? You will absolutely get a problem like this. And it all stems from this. So you have to mix two different math techniques here. Cross multiply. Okay? You have to be able to do that. And then you have to be able to factor as well. Alright? Cross multiply and be able to factor. That said, there will be an easy problem on your test as well, and I probably should have started with that, and I apologize. You will get a problem that looks like this instead. X plus 4 over x minus 2 is equal to negative 6 over 4. Oh. Hold on. That is another harder example. Where are my easy ones? Oh, here, sorry. Negative 2y. Minus 5 over y plus 7. And I think I did this one in class several times. The other one I only did once. Did I change a problem? That was a 2. Sorry about that. There's the original problem. Okay, and we would still cross multiply and divide. So cross multiply. Negative 2y times 5 is negative 10y. Negative 5 times 5 is negative 25. Put your equal sign and then do that times the bottom. So 2 times y is 2y. 2 times 7 is 14. Now let's combine like terms. I'm going to go ahead and add 10y here. And I'm going to subtract 17. These will cancel out. Those will cancel out. Negative 25 minus 17 is going to give you a negative 42. Bring down your equal sign, and then 2y plus 10y is 12y. From here, go ahead and divide by 12. And you'll notice these 12s will cancel out, but you can't leave this as your final answer because it's not simplified. Let's see. 3 actually goes into both the top and the bottom. So let's go ahead and divide both the top and the bottom by 3. 42 divided by 3 is 14. And then 12 divided by 3 is 4. This goes a little further. We can actually simplify by dividing by 2. My mistake, 6 happened to go in both. So negative 14 divided by 2 is negative 7. And 4 divided by 2 is 2. Okay. If you had typed this in your calculator, by the way, you would have gotten a decimal. And I will accept that decimal answer. I am allowing calculators on this one. So if you had typed it in, you would just end up with negative 14. I'm sorry, you would end up with negative 3.5 for this one. Alright, so those are all the problems that are going to show up on our Algebra 2 test. Just to review real quickly. Oh, my paper's all out of order. You had quadratic formula. Alright, quadratic formula. And then you also had the discriminant, which is started here and then finished on this page. So you have quadratic formula, discriminant. You also had adding and subtracting complex numbers. You also had FOIL of complex numbers. Then you had simplifying complex numbers. So simplifying complex numbers and then simplifying their radicals. Okay? And you'll see simplifying complex numbers with I in the denominator. And then rational equations. Those are your topics for the test. Remember, that is from section, I want to say, let's see, 2.3. Nope. That is from page 83, so section 2.4, all the way up to about page 110 is where your problems end. Alright, so about 27 pages of material. In any case, hopefully that all works for you. You will get a couple of each of these types of problems on the test. Alright, best of luck, do study well, and prepare. Have a wonderful weekend, and I will see you guys come Tuesday. Bye.